This video gives a solution to Effective Maths 2, page 179, question 8. In this question, we start with the ball on the ground and it gets projected vertically up into the air. Once it reaches this height, it falls to the ground and rebounds. It rebounds to 75% of the original maximum height. Of course, don't forget what goes up must come down, so it's going to fall back to earth again. It repeats this process, bouncing to 75% of the previous height each time. Let's just note where each bounce occurs. Note that the total distance travelled by the ball in each section here is twice the height that it reaches. And the total distance in each case is still 0.7 times or 75% of the previous total. I want to find the total distance to bounce 10, so I'm going to find the total distance on the up and down to bounce 1, the up and down to bounce 2, and so on and so forth. And I'm going to note my A and my R. I'm going to take A to be the total distance covered in the ascent and descent up to bounce 1. The R is 0.75 because I've got 75% of the height attained each time. And N is going to be 10. I'm going to use the formula Sn equals A bracket 1 minus R to the N over 1 minus R. And so to find S10, I'll fill my values in and I'll get 75.49 meters. In part 2, I want to find the total distance travelled by the ball before it comes to rest. So I'm going to assume that it infinitely bounces and I'm going to find the sum to infinity. The sum to infinity is A over 1 minus R. I can retain my A and R values from part 1. I fill into the formula and I get a solution of 80 meters as the total distance travelled by the ball before it comes to rest.